Hi BC. I hope you're enjoying your extra long weekend. Fortunately for all of us, we only miss one day of BC Calc. Only Wednesday because we're gonna drop tomorrow anyway. So I thought I would just create a really quick screencast here to mop up one thing that we didn't cover when we did the fundamental theorem, um, and we'll have a little bit of AP style homework practice. Um, so uh, let's get right into it. Okay, so if I have an accumulation function here, h, where h is sort of the amount of area that we accumulate between 1 and x underneath the curve t squared minus 4, right? We're all very good at saying, oh, if I have this, if I'm trying to take the derivative here, I just plug in this x, we just plug in this x in here for t, and I get something like x squared minus 4, right? We're all very, very happy with this. But what if that x up there was a more complicated function of x? What if it was something that wasn't just x itself? What if f, big F of x was 1 to sine x of t squared minus 4 dt. Okay, so now this is a little bit trickier, right? Is it as simple as just saying, oh, it's just going to be sine squared x minus 4? It turns out, no, it's not, okay? So what we're going to do here is we're essentially going to modify this, right? We already know this h, and these functions are obviously very, very related, right? So we have this h up here. I'm going to let g of x be equal to sine x, okay? And then I want you to possibly pause the video, maybe you don't need to, right? But I want you to absorb the fact that f of x is really just h of g of x, right? It's really just plugging in sine x in for x in the function h, right? That's all this really is, and g of x, of course, is sine x. So if that's the case, well, then f prime of x is just h prime of g of x times g prime of x, okay? Which just makes sense from the chain rule. So for example, in this case, f prime of x would therefore be equal to, well, what's h prime? We said h prime is x squared minus 4, but we're plugging in g of x, right? Here we have x squared minus 4. So we'd be plugging in g of x in there, which is just sine, right? So that'd be sine of x squared minus 4, or sine squared x, either one, right? That's this first part here, times the derivative of g, cosine x, right? So that's what the derivative of f would be, right? F prime would be sine squared x minus 4 times cosine x because of the chain rule. So the big takeaway here is that anytime you have a more complicated function in a bound, upper or lower, if it's lower, I would suggest making it negative and making that the upper bound. But if you have a function other than x in the upper bound, you're going to take your derivative like normal, and you're just going to plug that function into the equation for t, and then you're going to use the chain rule on that function itself. So let's do one example. Okay, so let's let f be I don't know, what's something fun? Let's do 3 to t, what am I doing? X, not t, x squared, and let's do tan t in here, dt. Well, if that's the case, right, then f prime of x is going to be equal to just this function with x squared plugged in, tan of x squared, remember that's h prime of g of x, right? H prime right here, we would be letting h of x would really be the integral from 3 to x of tan t dt. So h prime is just tan x, right? That's really what we're doing over there. Okay, tan of x squared, and my g, of course, my g of x is just x squared, right? Times g prime of x, 2x, right? So the big takeaway again, right? It's what you think it should be here times the chain rule, right? Times the derivative, or not times the chain rule, times the derivative of that top thing using the chain rule. Okay? So you're going to have some practice with this. and I hope you guys stay warm over the next few days.